There is a patch of sky in the direction of the constellation Eridanus where the universe is colder than it is allowed to be. Not colder by a little, the oldest light in existence, the microwave glow left over from the birth of the cosmos, runs about 150 millionths of a degree below the temperature of everywhere else. It has a name, the cold spot. And when astronomers looked at what sits in front of it, they found a hole. A region of space hundreds of millions of light years across, drained of galaxies. A supervoid. The obvious story wrote itself. The emptiness chilled the light on its way to us. Then they ran the numbers through the standard model of cosmology. The void can account for, at most, 10 to 20% of the cold. The rest has no source anyone can find. This is not the only emptiness behaving strangely. The deepest voids in the universe are larger, emptier, and in places colder than the official model says they are permitted to be. Every explanation offered to close the gap has failed, and each failure points somewhere most cosmologists would rather not look. The first people to notice the problem were not looking for a problem. They were mapping emptiness, and the emptiness was bigger than the map allowed. In 1981, an astronomer named Robert Kirshner and 3 colleagues pointed their instruments at 3 narrow, separate slices of sky in the constellation Boötes, separated by some 35 degrees. Each slice was a pencil beam, a thin core sample drilled straight out into the cosmos, recording the distance to every galaxy it crossed. And in all 3 slices, at roughly the same distance, around 15,000 kilometers per second of redshift, the galaxies simply stopped. A gap. The same gap in 3 directions at once. When they mapped what that gap implied, the number was difficult to accept. A roughly spherical region of space about 330 million light-years across, 100 megaparsecs, with almost nothing inside it. In the volume they surveyed, a uniform universe predicted around 2,000 galaxies. In the first careful count, they found 3. 3 galaxies where 2,000 should have been. Later surveys patiently filled the emptiness in. 8 galaxies, then a handful more, then by the late 1990s around 60. 60 against an expectation of 2,000. The void did not go away, it only became better measured. One of the astronomers who worked that void, Greg Aldering, put its scale into a sentence that still lands. If the Milky Way had been sitting in the center of the Boötes void, he said, we would not have known there were other galaxies in the universe until the 1960s. Sit with that. An observer born inside that emptiness would have grown up believing their own island of stars was all that existed, because the nearest neighbors would have been too far away, too faint to see. The void is large enough to hide the rest of creation. I want to be careful here, because this is an investigation and not a sales pitch. The Boötes void, for all its scale, turned out to sit within what the standard model can produce. Voids of that size are not, by themselves, a crisis. Sources are explicit about this, and an honest case file says so out loud. The Boötes void is not the anomaly. It is the thing that taught us to take the emptiness seriously. It was the first sign that the universe is built far more out of nothing than out of something, and that the nothing has structure. The voids are not isolated holes. They are part of a pattern. In 1989, 2 astronomers at Harvard, Margaret Geller and John Huckra, were systematically measuring the distances to thousands of galaxies, slice by slice, in what was called the second CFA redshift survey. What emerged from the data was not a random scatter of galaxies filling space evenly. It was a structure. Galaxies strung along immense walls and filaments, wrapped around enormous empty bubbles, like soap film around pockets of air. And one of those walls was so large it broke the expectations of everyone who saw it. They called it the Great Wall. A sheet of galaxies roughly 500 million light-years long, 300 million wide, and only about 15 million thick. A cosmic membrane 200 million light-years from Earth. When Geller described it to the press, she did not reach for triumph. She reached for disbelief. People did not believe there were structures this big, she said. And then, more quietly, we are sort of like people mapping the new world. A reference entry on that survey records the reaction more bluntly still. The Great Wall surprised astronomers because its size was larger than could be produced by gravitational collapse since the beginning of the universe. Read that again. Larger than could be assembled in the entire age of the universe. That was the 1989 reaction, and the Standard Model has since stretched to accommodate walls and voids as ordinary features of the cosmic web. But notice the shape of what happened. We found emptiness on a scale we did not expect. We found structure on a scale we did not expect. And each time, the model was widened to fit the observation after the fact. Hold that thought, it will matter later. Because there is a difference between a model that predicts what it finds and a model that is adjusted to survive what it finds. And the scale kept climbing. The Bootes void, at 330 million light-years, is the largest of the classic voids. It is not the largest emptiness we have found. In 1988, astronomers mapped the giant void in the constellation Canes Venatici, a region better than 1 billion light-years across, more than 1.5 billion light-years away, with 17 galaxy clusters scattered through its enormous interior. Larger still, the South Pole Wall, charted in 2020 by Daniel Pomered and colleagues, is a filament of galaxies stretching across roughly 420 million light-years, about 1/10 of the speed of light in redshift terms, that had hidden in plain sight behind the band of our own galaxy. And the Sloan Great Wall, a superstructure of galaxies bounding the voids around it, runs something like 1.5 billion light-years end to end. The deeper the surveys reached, the more the universe resolved into the same motif. Vast bounded nothing, threaded by luminous walls. Picture a marine biologist who has spent a career studying a single lagoon. She has catalogued every species, mapped every current, and her models describe the lagoon perfectly. Then she is told the lagoon opens onto an ocean that runs for billions of miles in every direction, with a chemistry her models were never built to handle. Nothing she learned about the lagoon is wrong. None of it describes the ocean. That is the position cosmology keeps finding itself in. Each survey a wider shore, and each wider shore behaving in ways the model of the smaller one did not foresee. What does it mean that the first thing the universe showed us, when we finally mapped it in depth, was emptiness we were not prepared for? There is a theory of how the voids come to be, and it is worth a moment because it shows how careful the bookkeeping has to be. In 2004, Ravi Sheth and Rien van der Weijgaert modelled the birth and growth of voids using what is called excursion set theory. It tracks two competing fates. A small void nested inside a larger void simply grows along with it. That is the void-in-void process. But a void embedded inside a larger, overdense region meets a different end. As the surrounding density collapses inward, the little void is crushed out of existence, squeezed shut. That is the void-in-cloud process. The mathematics is a two-barrier counting problem, descended from the Press-Schechter formalism of 1974. You count the density histories that dip below the threshold to become a void without ever having crossed the threshold to collapse. From that, the theory predicts a characteristic distribution of void sizes. A universe that should be filled with voids of preferred, predictable scales. It is elegant, and it is also revealing in its failure modes. The authors themselves acknowledge that real voids are not spherical, and that a naive version of the model produces an absurdity. The total volume of all predicted voids can exceed the volume of the universe itself, which is impossible, and has to be patched by the void-in-cloud correction. I point this out not to mock the theory, which is genuinely useful, but because it is a clean illustration of the pattern running through this entire file. The model of the emptiness, left to its own logic, predicts more emptiness than there is room for, and must be corrected by hand to fit the world. What does it mean that even our theory of nothing overflows the universe and has to be trimmed back to make it fit? For a while, the voids were a curiosity. Then, in 2004, a team led by Patricio Vielva was sifting through the map of the cosmic microwave background recorded by NASA's WMAP satellite. It was the most detailed picture then taken of the radiation left over from roughly 380,000 years after the beginning, the moment the universe first turned transparent. That radiation should be almost perfectly smooth, the same temperature in every direction to within tiny, random ripples. And in the southern sky, in the direction of Eridanus, they found a cold region that the random ripples could not easily explain. It was centered near galactic coordinates of about 209 degrees longitude and -57 latitude, with a core a few degrees across, surrounded by a faint, warm ring. The temperature decrement at the center ran on the order of 150 millionths of a degree below the mean. It was not supposed to be there. When Europe's Planck satellite mapped the same sky years later with greater precision, the cold spot did not vanish. An overview of the Planck mission stated the situation with unusual candor. The large-scale anomalies, including the cold spot, have both been independently confirmed by Planck, so they are real, but their interpretation is unclear. Real, but unexplained. What does it mean that the oldest light in the universe carries a stain that the people who confirmed it cannot account for? In 2007, 3 researchers, Lawrence Rudnick, Shay Brown, and Lilia Williams, went looking for something that might sit in front of the cold spot and cause it. They examined the NVSS radio survey, a catalogue of distant radio galaxies in that direction. And they found a dip, a deficit in the number of radio galaxies, suggesting a vast underdensity, a supervoid, lying along the line of sight to the cold patch. Here, it seemed, was the culprit, a hole in the matter of the universe, large enough and empty enough to leave a mark on the ancient light passing through it. That is where the case appeared to close. A cold patch and an empty region in front of it, cause and effect. The file could have ended there. It did not end there, because when other astronomers tried to make the void actually produce the cold, the arithmetic refused to cooperate. To understand why, you have to understand the mechanism by which a void can chill light at all. And that mechanism is the first piece of hard evidence in this case. The effect has a name, the integrated Sachs-Wolfe effect, first described by Rainer Sachs and Arthur Wolfe in 1967, and extended to evolving structures by Martin Rees and Dennis Sciama in 1968. It works like this. A photon of the cosmic microwave background, traveling across billions of years to reach our instruments, occasionally falls into the gravitational well of a large structure and then climbs back out the other side. In a static universe, the energy it loses climbing out exactly cancels the energy it gained falling in. Nothing changes. But the universe is not static. It is expanding, and that expansion is accelerating, driven by what cosmologists call dark energy. So, while the photon is inside the well itself is being stretched and flattened. The photon climbs out of a shallower well than the one it fell into, and keeps a little of the energy it should have given back. Through an overdensity, the photon comes out slightly hotter. Through a void, a region where the photon climbs into a hill of low density and then descends, it comes out slightly colder. The equation that governs this is compact. The fractional change in temperature, delta T over T, equals 2 over the speed of light squared, times the integral along the photon's path of the rate at which the gravitational potential changes with time. In planar terms, the colder or hotter the photon ends up depends on how much the gravitational landscape shifted while the light was crossing it. A deep, evolving void leaves a cold imprint. The size of that imprint is not a matter of opinion, it is a number you can calculate. So they calculated it. And here the case breaks open. For a supervoid of the size found in front of the cold spot, the standard model predicts a central cooling of roughly 20 millionths of a degree. The observed cooling is around 150 millionths of a degree. The void is real, but it is between 5 and 8 times too shallow to produce the cold that sits on top of it. This is not a fringe claim. It is the conclusion of the people who confirmed the void exists. In 2022, a team led by Andras Kovac used the Dark Energy Survey, one of the most sensitive galaxy surveys ever conducted, to map the matter in the cold spot's direction. They confirmed the Eridanus Supervoid as a genuine underdensity, detected in their lensing mass maps at a signal-to-noise ratio above 5. The void is there. It is not a statistical ghost. And then, in the same paper, they stated the problem in their own words. Assuming the standard model, only about 10 to 20% of the observed temperature depression can be accounted for via its integrated Sachs-Wolf imprint. The thing that was supposed to be the answer explains, at most, a fifth of the question. It got worse for the simple explanation. The same survey found that the gravitational lensing signal of the supervoid, the way its missing mass bends the light of galaxies behind it, was about 30% weaker than the standard model predicts for a feature like it. And a separate team, led by Rory Mackenzie and Tom Shanks in 2017, mapped roughly 7,000 galaxies in the inner 5 degrees of the cold spot using the 2DF and VST Atlas surveys. They found voids, yes, at redshifts of about 0.14, 0.26, and 0.30. But they were interspersed with small overdensities, and on a scale, they wrote, insufficient to explain the cold spot through the standard ISW effect. More damning still, when they compared the galaxy distribution toward the cold spot against a control field elsewhere in the sky, the two regions looked statistically similar, but only one of them had a cold patch sitting on it. Their conclusion was quiet and devastating. The cold spot may have a primordial origin rather than being due to line-of-sight effects, meaning it may not have been imprinted by anything in front of it at all. It may have been there from the beginning, baked into the oldest light, with no structure to blame. Other researchers, Seshadri Nadathur, Sean Hotchkiss and Subir Sarkar among them, drove the point home. In the standard theory of how structure forms, the probability of a void large enough and deep enough to imprint a cold spot-like profile through the ordinary ISW effect is, in their analysis, practically zero. The void cannot be the cause through the known physics. The known physics will not stretch that far. Think about being handed a garden hose and told to fill a reservoir that needs 1 million gallons in a fixed window of time. You run the hose at full pressure every second, and at the end you are still short. Not by a little, but by a factor of 5 or more. Swapping in a wider hose helps. It does not close the gap. At some point, the honest conclusion is not that you need to try harder with the hose. It is that the hose was never the thing filling the reservoir. The supervoid is the hose, the cold spot is the reservoir, and the water is coming, if it is coming at all, from somewhere the standard plumbing does not include. What does it mean when the one explanation that was supposed to close a case can only ever account for a fifth of it, no matter how generously you run the numbers? Now I owe you the honest counterweight, because a real investigation tests itself. The cold spot's raw statistical strangeness has been overstated in popular accounts. The early analyses flagged it at around 4 standard deviations, roughly a 1 in 15,000 oddity. But that number does not survive scrutiny. When you account for the fact that researchers went looking across the whole sky and could have flagged any unusual feature anywhere, what statisticians call the look elsewhere effect, and for the freedom they had in choosing exactly how to measure it, the significance falls to about 2 standard deviations. The WMAP 3-year analysis found that around 1 to 2% of purely random simulated skies contain a cold region at least this extreme. 1 to 2% is unusual. it is not impossible. A single cold spot taken alone could be a fluke of the one sky we were dealt. So if the cold spot were the only strange thing, the case might close with a shrug. Here is why it does not. The cold spot is one anomaly among several, and the others are not 1 or 2% oddities. They are 5 and 6 standard deviation problems. The kind of number that, in any other branch of physics, would be called a discovery. There is another problem hiding inside the voids themselves, and it concerns what is missing from them. The standard model of how galaxies form predicts that voids should not be perfectly empty. They should be sparsely populated by enormous numbers of small, faint dwarf galaxies, the low-rung structures that gravity assembles first. Rien van der Weijgaert and colleagues, who led the Void Galaxy Survey, studying dozens of galaxies stranded inside voids, put the expectation bluntly. Voids are expected, in their words, to be teeming with dwarfs and low-surface brightness galaxies. They are not. The density of faint galaxies inside voids runs at roughly 1/100th of the cosmic mean, far fewer than the model says should be there. The discoverer of this discrepancy, the Nobel laureate Jim Peebles, gave it a name: the void phenomenon. It remains a genuine open tension. The mainstream response is that energy feedback and the early reheating of the universe suppressed dwarf formation in thin regions, and that response may well be right. But notice the structure once again. The model predicted teeming voids. The voids came back nearly sterile, and an additional mechanism was added afterward to explain the gap. I owe you, here, the strongest piece of evidence that runs the other way, because a real investigation reports what acquits the suspect as carefully as what convicts it. Cosmic voids are not only anomalies, they are also tools, and one of those tools mostly vindicates the standard model. Because a large, stacked average of many voids is very nearly spherical, voids can be used for what is called the Alcock-Paczynski test, a geometric check named for a 1979 method, which asks whether a sphere still looks spherical once you convert its redshift into distance. It only does if you assumed the correct cosmology. Researchers including Nico Hamaus, Alice Pisani, and Paul Sutter have applied this test to hundreds of thousands of voids in the Sloan surveys, and the result, broadly, is consistent with the standard model. A dark energy equation of state near -1, a matter density in line with Planck. So the geometry of voids, taken in bulk, does not break the model. That matters, and I will not hide it. The anomalies in this file are specific and sharp. The cold spots missing cold, the depth of the local hole, the lean of the quasars. Not a wholesale collapse of cosmology. The case is built on the sharp anomalies that survive scrutiny, not on a claim that everything is broken. An honest file convicts narrowly or not at all. What does it mean that the same emptiness can confirm the model in its geometry and contradict it in its contents? That the voids are both the best tool we have and the place the tools keep failing. This brings us to the cleanest, hardest piece of evidence in the entire file. It does not involve a void at all. It involves the single number that defines how fast the universe is expanding, and the fact that the universe appears to be giving two different answers. The number is the Hubble constant, written h0. It comes from the simplest important law in cosmology, the Hubble-Lemaitre law. Velocity equals h0 times distance. A galaxy's recession velocity equals the Hubble constant multiplied by its distance from us. The farther a galaxy, the faster it flees, and the constant of proportionality is the expansion rate of the cosmos itself. Georges Lemaitre wrote it down in 1927. Edwin Hubble published the observations in 1929. For nearly a century, it has been the backbone of measuring the universe. There are two rigorous ways to measure it, and they should agree. The first reads it from the early universe. Take the Planck satellite's exquisite map of the cosmic microwave background, feed it through the standard model, and it tells you the expansion rate with extraordinary precision. 67.4 kilometers per second per megaparsec, give or take half a unit. The second reads it from the nearby universe, the cosmic distance ladder. Measure the distances to pulsating stars called Cepheids, use them to calibrate exploding stars called Type 1a supernovae, and watch how fast the local galaxies recede. The SH0ES team, led by Adam Rees, did exactly this and published in 2022 a value of 73.04, give or take about 1. 67 from the dawn of time. 73 from the present day. A gap of about 9%. And both teams have spent years hunting for the mistake that would make it go away. Think about two surveyors hired to measure the same river. One measures from the mountain source, the other from the sea mouth. Different equipment, different crews, different methods. When they compare notes, their numbers should converge. If they differ by 9%, the first assumption is a mistake in one of the surveys, and you recheck everything. But suppose both crews recheck 3 times, 4 times, and the gap holds. At some point you stop questioning the instruments. You start wondering whether the river you assumed was one river is actually 2. That is precisely where cosmology now sits. The discrepancy is not shrinking, it is hardening. Analyses put it at 5.3 standard deviations, and some 2024 work pushes it toward 5.8. To grasp that, 5 sigma is the threshold physicists use to announce a new particle. The Hubble tension has cleared it, and the obvious escape route, that the local measurement is contaminated by crowded, dusty star fields confusing the Cepheids, was sealed off when the James Webb Space Telescope, with its far sharper vision, re-observed those same stars between 2023 and 2024. The Webb data matched the earlier Hubble Space Telescope measurements. One 2024 analysis rejects the crowding explanation at 8 standard deviations. The error everyone hoped for is not there. Consider what it means when the building inspector who certified the foundation is the one now standing outside, saying something is wrong. Not a rival firm, not a critic who always doubted the design, the person who signed off on it. The distance ladder was supposed to be the place the discrepancy hid, and the sharpest new eyes ever built were sent specifically to find the flaw in it. They confirmed the measurement instead. When the tool you brought in to debunk the anomaly ends up certifying it, the anomaly stops being a suspect and becomes a fact of the case. Adam Rees, who has spent his career on this measurement, put it plainly. It's pretty clear there is a very strong tension. His colleague Dan Skolnick described the accumulating oddities as powerful hints that something is missing from the model. I want to be precise about attribution here, because precision is the whole point. That phrase belongs to Skolnick, reported through a news article, not to Rees and not to a formal paper. But the sentiment is now mainstream. No proposed fix, not early dark energy, not modified gravity, resolves the tension while staying consistent with everything else we measure. The leading interpretation is stark. Either there is new physics we do not understand, or there is a systematic error no one has been able to find despite looking for a decade. What does it mean when the single number that anchors our map of the universe gives 2 different readings, and the more carefully we measure, the further apart they move? And now the voids return, because one of the proposed explanations for that very tension is that we are sitting inside one. In 2013, 3 astronomers, Ryan Keenan, Amy Barger, and Lennox Cowie, measured the density of galaxies in the local universe using near-infrared light, which traces stellar mass well. What they found is that our cosmic neighborhood, out to a radius of around 300 megaparsecs, roughly 1 billion light-years in every direction, appears to hold only about half the average density of matter for the universe as a whole. We may be living near the center of an enormous underdensity, a void about 2 billion light-years across. It has a name now, the KBC void, after its discoverers, or simply the local hole. And the underdensity shows up not in one kind of observation, but across the spectrum. Optical, infrared, X-ray, and radio counts all point the same way. Here is the quantity that matters. A void is described by its density contrast, the symbol delta, the difference between a region's density and the cosmic average divided by that average. A delta of 0 means perfectly average. A delta of -1 would mean perfectly empty. The KBC void, by the 2020 analysis of Moritz Hausbauer, Indranil Banik, and Pavel Krupa, has a density contrast of about -46% out to 300 megaparsecs. A region holding barely more than half the matter it should. And that is a problem, because the standard model permits the universe to be lumpy only up to a point. The expected variation in density on a scale of 300 megaparsecs, the cosmic variance, is, in their calculation, only about 4.8%. We are not looking at a 4.8% ripple. We are looking at a 46% hole. Their conclusion, stated in the paper's own abstract, is that the KBC void causes tension with standard cosmology at 6.04 standard deviations, and that combined with the Hubble tension, the standard model is ruled out at 7.09 sigma. They argue that the outflow of matter from such a void would inflate the locally measured expansion rate by about 11%, which is almost exactly the size of the Hubble discrepancy. The void, if it is real and that deep, could resolve the tension. But in their analysis, making it work requires abandoning standard gravity in favor of a modified theory, Milgromian dynamics. One anomaly, to be explained, demands rewriting another pillar. I have to give you the counter-evidence because the case is genuinely contested and an honest file shows both sides. In 2019, Kenworthy, Skolnick and Rees took 1,300 Type 1a supernovae spread across the sky and asked whether a large local void could be hiding in the data. Their answer was that the supernova distance-redshift relation is inconsistent, at the 4 to 5 sigma level, with local underdensities deeper than about 20%. By their measure, there is no void deep enough to bias the expansion rate. The two camps are still fighting. The void's defenders reply that the supernova analysis assumed voids have no effect on redshifts beyond a certain distance, an assumption their own models reject, and a 2025 reanalysis using a different distance dataset concludes that a local void remains a viable mechanism for alleviating the Hubble tension, even if not fully resolving it. Notice what the disagreement actually is. One set of measurements, near-infrared, X-ray, and radio galaxy counts, says we sit in a deep hole. Another set, supernova distances, says we cannot. Both are careful. Both are peer-reviewed. They contradict each other. The dataset conflict is not noise around the answer. The dataset conflict is the answer we do not have. What does it mean that two rigorous ways of measuring the same patch of universe return two incompatible pictures of where we live? There is a fourth anomaly, and it strikes at something deeper than any single void. The entire edifice of modern cosmology rests on one assumption, the cosmological principle, the idea that the universe, viewed on large enough scales, looks the same in every direction. No special places, no preferred direction. Take that away, and the equations that translate our observations into distances, ages, and the very existence of dark energy lose their footing. This is the keystone of the whole arch. Every other stone in modern cosmology leans on it. You can lose a decorative block from the facade and the building stands. The cosmological principle is not a decorative block. It is the stone the architects set first and built everything else against, precisely because it could not be checked directly. You cannot step outside the universe to confirm it looks the same from elsewhere. We assumed it because the mathematics becomes tractable only if we do. And now the quasar dipole, at better than 5 sigma, is leaning on that keystone from an angle the architects swore nothing ever would. The mainstream reading is still that some unmodeled systematic, an artifact of how distant quasars are counted, an evolution in their brightness we have not pinned down, will rescue the assumption. That may be true. But the people defending the Keystone are no longer doing it from confidence. They are doing it from necessity, because the alternative is a renovation of the entire structure. What does it mean that the one assumption holding modern cosmology together is the one assumption we built precisely because we could never test it from the outside? In 2021, Nathan Seacrest and Subir Sarkar and their colleagues tested it. They took a catalogue of 1.36 million quasars, blazing galactic cores spread across the deep sky, mapped by the WISE infrared satellite, and asked a simple question. As the solar system moves through the universe, our motion should make quasars appear slightly more numerous in the direction we are heading, like rain striking the windshield more than the rear window. The size of that effect is predictable from our known velocity. They measured it. The direction came out close to expectation, but the amplitude, in their words, was over twice as large as expected, rejecting the purely motion-based interpretation with a p-value of 5 × 10⁻⁷. 4.9 standard deviations, the highest significance achieved in such a study to that date. A follow-up combining radio and infrared data pushed it to 5.1 sigma. A 2023 Bayesian reanalysis by Dam, Lewis and Brewer found the amplitude nearly 3 times expected, at 5.7 sigma. Subir Sarkar did not soften it. The cosmic dipole anomaly, he said, has thus established itself as a major challenge to the standard cosmological model, even if the astronomical community has chosen to largely ignore it. And in their peer-reviewed paper, the team wrote that the findings present a significant challenge to the cosmological principle and, by extension, the standard cosmological model. The foundation stone, challenged at better than 5 sigma. This is the pattern that turns a collection of curiosities into a case. The cold spot alone you can wave away as a 1% fluke. But around it stand the Hubble tension at 5+ sigma, the KBC void at 6 sigma, the quasar dipole at 5+ sigma. 3 independent measurements using different instruments and different physics, each individually at or beyond the threshold we use to announce discoveries, and each pointing at the same conclusion. The smooth, uniform, isotropic universe of the standard model does not match the universe we actually measure on its largest scales. The voids are not passive either. As the universe expands and dark energy drives matter apart, a void deepens. Its interior empties faster than the cosmic average, the inner regions outrunning the outer shells. The growth of any such density contrast is described by a single equation. The second time derivative of delta plus twice the expansion rate times the first derivative of delta, minus a gravitational term proportional to the matter density times delta, equals 0. In plain terms, gravity tries to deepen a void, while the expansion of space damps that deepening. A tug-of-war between clumping and stretching, with dark energy tilting the field toward emptiness. Voids are where dark energy wins most decisively. They are the regions of the cosmos most purely shaped by the thing we understand least. And an empty region does something that, at first, sounds impossible. It pushes. Not because emptiness has any power of its own. It has none. It is the absence of matter, not a force. But everything around a void is pulled toward the denser regions elsewhere, which means, relative to its surroundings, a void behaves as a source of repulsion. In 2017, mapping the flow of galaxies around us with the cosmic flows data, Yehuda Hoffman, Brent Tully, Daniel Pomered, and Hélène Courtois identified exactly such a feature. An underdensity they named the dipole repeller, sitting in the direction opposite the densest nearby supercluster. Together, the pull of the distant Shapley concentration and the apparent push of the dipole repeller account for the local group's motion of about 631 km per second relative to the ancient light of the cosmos. Half of what moves us, it turns out, is where the matter is. The other half is where the matter is not. What does it mean that the emptiness is not merely a backdrop to the action, but is steering us, that the holes in the universe are shaping the motion of everything we belong to? Even the cosmic microwave background carries its own cluster of these alignments. There is an unexpected weakness in the largest scale temperature variations. There is a strange alignment of the broadest patterns in the map, the quadrupole and octupole moments lining up with each other and with the plane of our own solar system. An arrangement so improbable and so seemingly parochial that Kate Land and João Magejo, who flagged it in 2005, named it the axis of evil. Here, too, I have to keep myself honest. This is a contested signal. Land and Magejo themselves later walked back some of the original strength of the claim, and whether the alignment is a genuine feature of the cosmos or a fluke of how we measure a quantity we have only one sky to sample remains disputed. But Planck confirmed the alignment is really in the data, and the unsettling part is not the statistics alone. It is the direction. Of all the axes the largest structures in the universe could point along, it tracks this one. The plane of the small planetary system from which we happen to be looking. The most likely innocent answer is that we are pattern matching a coincidence, or that some subtle contamination from our own solar system leaks into the map. The most likely answer is probably the boring one. But the physicist Lawrence Krauss put on the record what the alternatives would mean if the boring answer fails. The new results are either telling us that all of science is wrong and we're the center of the universe, or maybe the data is simply incorrect. Or maybe it's telling us there's something weird about the microwave background results, and that maybe there's something wrong with our theories on the larger scales. All of science is wrong. Or we are at the center. Or our theories fail on the largest scales. Those were the options a working physicist laid on the table. Now we test the explanations, one at a time, and see which survive contact with this evidence. The first explanation is the gentlest. Nothing is wrong at all. Each anomaly is a statistical fluctuation, and we are pattern-seeking animals stringing unrelated flukes into a false story. This deserves a fair hearing because it is partly right. The cold spot's raw significance really does soften under the look elsewhere correction. Any one of these features, in isolation, has an innocent reading. But the explanation fails where the evidence concentrates. It is one thing to draw a single unlikely card. It is another to draw the Hubble tension at 5 sigma, the KBC void at 6, and the quasar dipole at 5+. Independent draws, different decks, and call the convergence coincidence. At some point, they are all separate flukes, stops being skepticism and becomes its own act of faith, held precisely because the alternative is uncomfortable. The fluke explanation does not survive the pattern. It survives only the cold spot taken alone. The second explanation is more ambitious, that we are seeing the fingerprints of other universes. In the theory of eternal inflation, our cosmos is one bubble among an unending froth of them, and a collision with a neighboring bubble in the deep past could have stamped a circular cold or hot disk into the microwave background, which is exactly the kind of feature the cold spot superficially resembles. Researchers took this seriously and tested it properly. Stephen Feeney, Matthew Johnson, Daniel Mortlock, and Hiranya Peiris built a Bayesian search of the WMAP data for the signatures of such collisions. To their credit, the method avoids cherry-picking. It does not assume the cold spot is special. It scans the whole sky. They found 4 features marginally consistent with bubble collisions, one of them the cold spot. And then they stated, honestly, exactly what they had. These features are on the edge of our sensitivity thresholds, and so should be considered only as a hint. No statistically significant detection. None since. So how do we weigh the multiverse as an explanation? Carefully, because it is unfalsifiable in a way that should make any investigator wary. No other bubble has been observed, measured, or detected. By construction, the theory can accommodate almost any data. If we see a circular mark, it is a collision. If we see nothing, the collisions were too gentle or too far. A proposal that is compatible with every possible observation forbids none of them, and a claim that forbids nothing explains nothing. Even granting the entire infinite ensemble, the machinery that spawns the bubbles, the inflating field, the laws that govern it, would itself demand an origin and an explanation. The multiverse does not remove the question of why there is finely ordered structure at all. It postpones it behind an infinity of unobservable worlds and hopes the question gets lost on the way. Notice the move too. Cosmologists who reject a designed universe as unscientific because it invokes something unobservable will, to avoid that conclusion, invoke an infinity of unobservable universes. If one unseen cause is forbidden as unscientific, a limitless number of unseen causes cannot be the rescue. This is not naturalism standing on evidence, it is naturalism of the gaps. The third explanation is the most respectable and the most quietly evasive. Science will eventually explain all of it. New physics will emerge, a systematic will be found. The tensions will dissolve as our predecessors' anomalies dissolved. And sometimes that is exactly what happens. The history of the field is full of puzzles that yielded to better data. This explanation cannot be dismissed, and I will not pretend otherwise, but it is worth naming what it is. We do not know yet, but we will, is not evidence. It is a promissory note written against a future that may or may not pay out. After a decade of the most determined effort, Webb cross-checks, control fields, reanalyses, the Hubble tension has not shrunk. It has grown. The gaps have not closed, they have widened. To insist that the resolution is surely just over the horizon, when every new measurement pushes the horizon further away, is not the voice of evidence. It is the voice of a prior commitment that has decided in advance what the answer must be. There is a name cosmologists use to mock religious explanation: the God of the gaps. Honesty requires admitting that science of the gaps, deployed to hold a conclusion at bay indefinitely, is the same move wearing the opposite coat. I will be blunt about the explanations further out, because the title of this case promises something hiding in the voids, and there are people who fill that emptiness with stranger things. There is the claim of dark flow, that whole clusters of galaxies are streaming in a single coherent direction, pulled by structures beyond the edge of the observable universe. The method behind it leans on a subtle effect. When a cluster of galaxies moves relative to the background radiation, it slightly shifts the energy of the photons that scatter through its hot gas by an amount proportional to the cluster's line-of-sight velocity and the density of that gas. This is the kinematic Sunyaev-Zeldovich effect, written as a fractional temperature change equal to minus the cluster's velocity over the speed of light times its optical depth. Alexander Kashlinsky's team used it to claim, in 2008, a coherent bulk motion at 3 to 4 sigma toward a single patch of sky. But the Planck collaboration, examining more than 1,000 clusters, found no such flow, bounding any bulk motion to below 254 kilometers per second, several times under Kashlinsky's figure. The signal is disputed and unconfirmed. I raise it not to lean on it, but to be complete. It is exactly the kind of evidence that would be thrilling if it held, and exactly the kind an honest investigator refuses to bank on while it does not. And there is the furthest idea of all, that the structure of the cosmos is engineered, that the universe is a designed or simulated artifact. I want to be exact because rumors travel faster than facts. There is a frequently repeated claim that a specific physicist published a paper showing the universe is a programmed simulation. I checked it. That paper does not appear to exist. The attribution is mistaken. The general simulation hypothesis remains philosophy, not physics, and recent work argues it is very nearly impossible to realize. I am not going to build a case on a hole, even a hole this large. Speculation is not evidence, and an honest file says so when it reaches the edge of what the data can carry. So strip away what fails. The supervoid cannot make the cold spot. It falls 5 to 8 times short. The pure fluke explanation cannot survive the convergence of 5 and 6 sigma anomalies. The multiverse forbids nothing and therefore explains nothing. Science will explain it later has been getting less true, not more, for 10 years. Dark flow is unconfirmed. The engineered cosmos claim rests on a paper that is not there. Every explanation that tries to make the anomalies ordinary has either failed the arithmetic or fled into the unobservable. And underneath all of them sits a deeper fact that none of them touch. A fact about how finely the universe is set, which is where this investigation has been heading the whole time. Step back from the voids for a moment and look at the rules the whole structure runs on. The cosmic web, the walls, the filaments, the supervoids, the cold spot, the local hole. All of it is matter and energy arranging itself under a handful of fundamental constants. Change those constants and there is no web to map, no voids to fall into, no observers to notice. And when you examine the values those constants actually take, you find something the anomalies only hinted at. The precision is not approximate. It is absurd. Consider the energy of empty space. Quantum field theory, our best, most rigorously tested framework for the behavior of matter at small scales, predicts that the vacuum itself, space with everything removed, should seethe with energy. You can calculate how much. And when dark energy was measured, the faint outward pressure accelerating the expansion of the universe, physicists compared the prediction to the observation. The theoretical value exceeds the measured value by a factor of roughly 10 to the power of 120. That is a 1 followed by 120 zeros. 3 cosmologists describing it called it among the worst theoretical predictions in the history of physics. The observed dark energy density is about 6 times 10 to the minus 10 joules per cubic meter. A whisper. The prediction is a scream 120 orders of magnitude louder. For the universe to exist with structure in it, that colossal vacuum energy must be cancelled, almost but not quite perfectly, leaving a residue tuned to something like 1 part in 10 to the 120. I need you to feel that number, because numbers this size stop meaning anything. Picture a combination lock, not with 3 dials, but with a row of them, each running from 0 up through a trillion. The lock opens only if every dial is set to 1 exact value. Not close, exact. The probability of hitting that by spinning them blindly is a number with no analogy in human experience. The cosmological constant is a dial like that, and it came preset. Before any star formed, before the first void opened, the energy of empty space was balanced to a precision that no process we know how to write down produces on its own. Take a moment with that before we go on. The value that governs dark energy is captured in a single quantity cosmologists call the equation of state, written W, the ratio of dark energy's pressure to its density. If dark energy is a true cosmological constant, an unchanging energy of the vacuum, then W equals exactly -1. Planck's measurement gives W of -1.03, give or take 3/100ths, sitting right on -1. In 2024, the Dark Energy Spectroscopic Instrument hinted that W might not be perfectly constant after all, that it may evolve, with a present value nearer -0.73. That result is real, but it is contested. Several analyses argue it depends on the choices made in fitting the data, and even the people reporting it caution that a compelling theoretical interpretation is, in the field's own words, presently lacking. I flag it not as a conclusion but as a live question. The point that survives the debate is this. Whether W is exactly -1 or drifting near it, the value sits in the narrow band that permits a universe with structure, with chemistry, with the slow gravitational assembly of galaxies, walls, and voids. A little more outward pressure and nothing ever clumps. A little less and it all recollapses. It is not only the vacuum energy, the geometry of the universe is balanced on the same knife. Planck measures the spatial curvature of the cosmos and finds it flat to within about 0.2%. the total density of the universe matched to the one critical value that yields a flat, structure-permitting geometry, when the natural range of possibilities spans wildly in either direction. Flat universes are not the generic case, they are the threaded needle. What does it mean that the universe is empty in places it should not be, lopsided in a direction it should not have, expanding at a rate it cannot agree with itself on, and underneath all of it, tuned to a precision that the best physics we possess cannot explain and can barely write down? This is the part of the case that stays with me. Not the scale of the voids, the scale is merely large, and largeness, after a while, goes numb. It is the precision. The voids drew us in because they were anomalies, places where the smooth model failed. But chasing the failures led somewhere the failures themselves did not predict. To a set of constants holding the whole thing in a configuration so exact that coincidence stops being a description and becomes a refusal to describe. Precision requires decision. A value selected from a near infinity of alternatives and selected to the edge of what permits anything to exist is not the signature of an accident. Accidents are sloppy. This is not sloppy. Now let me reconstruct what the evidence taken together actually says played forward, as a sequence, the way you reconstruct events from a scene. On the largest scales we can survey, the universe is not the smooth, even, directionless thing the standard model assumes. It is structured into a web of emptiness and filament, and the emptiness dominates. Most of the volume of the cosmos is void. We sit, the local measurements suggest, inside one of those underdensities, a hole a billion light-years deep in every direction, and the matter streaming outward from it may be the very thing inflating the expansion rate we measure nearby. In one specific direction, the same rough region as the cold spot, the ancient light is colder than any structure in front of it can explain, by a factor of 5 to 8. And the simplest reading on the table is that the coldness was there from the beginning, written into the first light. Across the whole sky, the count of distant quasars leans in a direction it should not, by twice the amount our motion allows, straining the assumption that the universe has no preferred axis. The broadest patterns in the oldest light line up with one another, and, disturbingly, with the plane of our own small solar system. And beneath every one of these features, the constants that make structure possible are set with a precision no known process accounts for. That is the reconstruction. A universe finely set, and on its grandest scales not behaving like the random, self-sufficient machine we were taught it was. What does it mean for us, for you, watching this, here, now? It means the map is suspect at its foundation. Every distance to every galaxy, every age we assign to the cosmos, the inferred amount of dark matter and dark energy, the entire composition of reality as modern science reports it, all of it is computed on the assumption that the universe is smooth and the same in every direction. That assumption is the thing cracking at 5 and 6 sigma in measurement after independent measurement. We have built a precise and beautiful model of the cosmos on a premise the data is, quietly and persistently, rejecting. Before I continue, sit with that for a moment. The confidence with which the universe is usually explained to you, the settled, finished, no creator required machine, is resting on a flaw that the people who built it are watching crack. Go further into what that cracking flaw would cost. The amount of dark matter, the amount of dark energy, the age of the universe, the distance to every galaxy in every catalogue, these are not measured directly. They are inferred by feeding our observations through the assumption of a smooth, even, directionless cosmos. If that assumption is wrong on the largest scales, if we sit off-center in a deep void, if there is a preferred direction the quasars are quietly tracking, then the inferences built on it inherit the error. It would not mean the science was fraudulent or the scientists careless. It would mean the foundation everyone trusted has a flaw that stays invisible until something asks of it precisely what it was not built to handle. A flaw that hides until the exact wrong question is asked is the most dangerous kind, because everything looks fine right up until it doesn't. What does it mean that the numbers you have been given for the size and age and contents of all reality rest on an assumption the universe itself appears to be contradicting at 5 and 6 sigma? And there is the part that genuinely unsettles me, the one I keep returning to not because it is comfortable, but because it is true. The voids were supposed to be the empty parts, the boring background between the interesting things. Chasing what was wrong with them did not lead to a tidy local fix. It led inward, to the constants, to a vacuum energy tuned against its own prediction by a factor with 120 zeros, to a flatness threaded to a fraction of a percent. The emptiest places in the universe pointed, in the end, at the most exquisitely set thing about it. That is not where I expected the trail to run when I opened the file. And here is where I, as the one who has worked this file, have to tell you where the evidence leaves me. I am not going to pretend to a neutrality I do not have. I have followed the trail, tested every explanation that survives a fair hearing, and watched each materialist account of why all this needs no cause either fail the arithmetic or vanish into worlds we can never see. So I will say plainly what I think the evidence points to. Start with the oldest question, the one the voids force on you when you really look into them. Why is there something rather than nothing? Some physicists answer that the universe came from nothing, that empty space through quantum fluctuation gave birth to everything. But look closely at what they mean by nothing. They mean a quantum vacuum. Fields, energy, the laws that govern fluctuation. That is not nothing. That is a very structured, very lawful something, and they have quietly renamed it to borrow the words force. True nothing has no fields, no energy, no laws, no potential to fluctuate. From true nothing, nothing comes. 0 plus 0 is 0, no matter how long you wait. And yet a universe exists, finely tuned, structured, vast. So something has always existed. The only question worth asking is what? Unconscious matter with no explanation for its own precision, or an intelligent cause. And the matter cannot be the terminus, because matter and energy show no capacity to set their own constants. A cause that explains the universe must be external to the space and time that began with it, and must be itself uncaused. Otherwise you fall into an infinite regress of causes that never starts, and therefore never arrives at us. You cannot stack dependent causes backward forever. If every link needs a prior link, the chain never begins, and the fact that we are here proves it began. The chain terminates in something uncaused and self-sufficient. The materialist already accepts this. They simply place the eternal, uncaused thing in unconscious matter or an unobservable multiverse. The question is whether an uncaused cause that produces information, order, and constants tuned to one part in 10 to the 120th is better described as mindless or as something with knowledge and will. When you find a structure exhibiting that kind of precision, you do not, in any other context, conclude it set itself. Picture a locksmith examining a lock of extraordinary complexity. He can describe every tumbler, every spring, every tolerance. Describing the mechanism perfectly does not tell him the lock built itself. The completeness of his description points the other way, toward a maker with intent he never saw but can infer from the work. The universe is a mechanism of incomprehensibly finer tolerance than any lock, and the same inference applies. Whatever set those constants existed before space and time, possesses power beyond the scale of what it made, possesses knowledge written into the exactness of the tuning, and possesses will, because among a near infinity of possible values, particular ones were selected. Power, knowledge, will. Those are not the properties of an equation or an accident. They are the properties every human civilization has named when it spoke of God. Imagine you are crossing a desert and you find, half buried in the sand, a book. Its pages are filled with coherent sentences, complex grammar, an argument that builds from chapter to chapter. You would not stand there theorizing about how the wind shaped the dunes into letters, how erosion happened to carve grammar, how a long enough stretch of time could press sand into prose. You would infer, instantly and correctly, an author, even though the author is nowhere in sight, even though you will never meet them. You infer the writer from the writing. The fine-tuning of the constants is information of exactly this kind. A configuration carrying meaning, in the sense that it specifies precisely a universe in which structure and observers can exist. Information has one known source. It traces back to intelligence. We accept that inference for a paragraph in the sand. The question is why we are asked to refuse it for the far more intricate text written into the vacuum energy and the curvature of space. And there is a tell in how the alternatives behave. Watch what happens when you ask a committed materialist the plainest version of the question, why is there something rather than nothing? They will redefine nothing until it quietly means something. They will reach for the multiverse, an infinity of worlds no instrument can see. They will say science will answer it eventually. What they will not do is answer it. The redefinition, the unobservable ensemble, the promissory note, these are the moves of a position defending a conclusion it reached before the evidence arrived, not following the evidence to where it leads. I want to be honest about the shape of this conclusion, because honesty is the only thing that separates an investigation from a sermon. I am not claiming the anomalies prove a creator the way a measurement proves the temperature. The Hubble tension does not have a deity hiding inside it. What I am saying is narrower and, I think, harder to dismiss. Every explanation that tried to keep the universe self-sufficient, the supervoid, the lucky fluke, the multiverse, the promise of future physics, has, on this evidence, failed or fled. And the residue they all leave untouched is a cosmos tuned with a precision that points, by every standard of inference we use everywhere else in life, toward intention. I do not think this is random. I have looked at where the trail runs, and I think something caused it. Something with the power to set the constants and the knowledge to set them exactly. That is not certainty about what lies beyond the last thing we can measure. It is the reading of an investigator about what the evidence inside the file most reasonably implies. And then the honest investigator names what the file still cannot close, because the case is worked, not solved. We do not know whether the cold spot is a primordial feature of the first light, an unexplained excess of some known effect, or a genuine fluke of the single sky we were given. We do not know whether the next generation of instruments, Euclid mapping the geometry of billions of galaxies, the dark energy spectroscopic instrument tracking whether dark energy truly evolves, will resolve the Hubble tension or deepen it. And there are walls we may never see past at all. We cannot observe anything from before the universe became transparent, around 380,000 years after the beginning, at a redshift near 1100. Before that, the cosmos is opaque, a curtain no telescope will ever part. Beyond the particle horizon, some 46 billion light-years away, lies a universe whose light has not had time to reach us and never will. And we have only one sky to measure, a single sample of a single cosmos, which means the largest scale questions may be permanently starved of the data that would settle them. The case stays open not because we are lazy, but because some of the evidence is, by the structure of reality itself, sealed away from us. What does it mean that the deepest questions a void raises are precisely the ones the universe is built to keep us from answering? That is as far as the evidence takes us. Here is the trail, laid back down in order. The Booty's void taught us the emptiness was real and structured. The CFA2 Great Wall showed the structure was larger than anyone expected. The cold spot in the direction of Eridanus marked the oldest light with a coldness no supervoid in front of it can explain. The integrated Sachs-Wolf imprint falls 5 to 8 times short. The Hubble tensions split the expansion rate of the universe into two numbers that will not reconcile, at better than 5 sigma, with the error everyone hoped for ruled out by the James Webb Space Telescope. The KBC void suggested we live inside a hole too deep for the standard model to allow, at 6 sigma. The quasar dipole leaned the whole sky in a forbidden direction, challenging the cosmological principle at its root. And beneath all of it, the constants of nature sit tuned to a precision the best physics we have cannot account for and can barely write down. Every explanation that tried to make that ordinary failed the arithmetic or fled to where no instrument can follow. What survived, for me, is the oldest inference there is. That precision implies decision, that a product implies a maker, that a cosmos this finely set and this strangely behaved is not the signature of nothing accidentally becoming everything. I do not think it is random. I think something caused it. If you want to follow the next case the whole way down, the next anomaly, the next file the standard model would rather we left closed, subscribe and stay with the investigation. And if this kind of case holds your attention, there is a related file waiting on the end screen. Another place where the universe stops behaving the way the official story says it must. Here is the last thing, and I will leave it with you unresolved, the way the evidence left it with me. You were told you live in a smooth, self-explaining universe that needs no cause and asks no questions of you. The deepest voids say otherwise. The oldest light says otherwise. The constants say otherwise. Something is hiding in the emptiness. Not a creature, not a monster, but a fact. That the nothing was never as empty, or as innocent, or as accidental as you were taught. And whatever set it this precisely has not signed its work in any language a telescope can read. The file stays open,